All right, so coming back in to kind of finish up that last example, so this will be part 2 of our video. When I identified the zeros, I kind of had to do two options, that there's two possibilities with this, and I don't really have enough information to tell. A lot of it has to do with whether or not, like if I was looking at this zero right here, the 1 or the 3, how do I know if it has single multiplicity, if it has a multiplicity of 3? I would really need to be able to tell whether it is crossing like a line or kind of having that point of inflection right there. And having a couple of points on either side is not going to be enough information for me to tell that. The same thing is true, I mean, actually with the 4 and the 2, for the 0 of 1, that when you're looking at that 0, the fact that it's going to bounce, really you can't tell whether it has a multiplicity of 4 or a multiplicity of 2. At least with the -3, 0, if we did have a lot of points and we could see that there was a point of inflection there, then we would tend toward the 3 as opposed to a multiplicity of 1. But I'm not going to really get too much into that because we really don't have enough information, and just say that there are two options for that. All right, so the next thing that I'm going to let you guys do is this next example right here. I'm going to let you guys do on your own, and then I'm going to let you guys answer a few pop-up questions about it to just check your understanding and make sure that you understand kind of what's going on with this problem. So if you would go ahead and using this table, answer questions A, B, and C, similar to what I did before, and then we'll move on to the next topic. All right, now I'm going to let you guys do a little bit of work here as well. I'm kind of enjoying this new way of doing the videos because I can actually get some feedback from you guys as you are going. So it's a little bit less of a passive watching, but you guys actually working through it, which I think is going to be much better for you in the long run. So when you're looking at the given function, if it's not already factored, then this is tying and bringing together what we've worked on in previous videos. So for our first thing that I would like you to do is go ahead and completely factor. Okay, so we're going to start with this completely factor. Let's call this A and B. So why don't you completely factor f of x and g of x using the techniques that we've had prior to this, and you will enter them into the pop-up questions. All right, so we have them factored now, and I've got my idea. Now it says identify the zeros and the multiplicity of the zeros. So we'll do that together here just to kind of show you what we're looking for. So in the first one, and you can do a lot of this in your head. I don't need you to write down the factors. We're getting to the point where we understand what's going on. But we definitely, from this first factor right here, I'm going to do the zeros here and then multiplicity right next to it. So negative 2x would equal 0 when x is 0. And its multiplicity, there's no power on that x, so its multiplicity would be 1. And then we have negative 2 would be the next 0, and it has a multiplicity of 2 when we look at it. Now from there, after we get the multiplicity of the zeros, we're going to sketch the graph of the function. Now, I would probably look at a couple of different things. One, you'll notice that there's no constant at the very end of f of x. So 0, 0 is going to be the x and the y-intercept. I also know that negative 2, 0 is going to be on there. That's going to be over here. So I have these two items. Our end behavior, okay, we're just doing a rough sketch here just to see what's going on. If we wanted to be more detailed, we would go and pick up a calculator and get some information or plug and chug some numbers. But this is a degree that is, let's kind of list what we know. It's odd. Our lead coefficient is negative. And whenever we have an odd with a negative lead coefficient, it's more of a decreasing function. So we know it's up on the left side and down on the right side. And then so we know that since we have a multiplicity of 1, it's got to cross like a line. It's going to have a minimum down here somewhere, and then it's going to bounce right here on that. Now, maybe if I want to get a little bit more detail into it, maybe I want to see how far down it goes, I might calculate, say, f of -1 just to get that value. We would have what? 2 minus 8 plus 8, so 2. Huh. Did you catch my mistake in that one? Did you see? I was like, I was pausing, going, something is not right here. Let's kind of take that out for a second. Where does it bounce? It bounces at the one that has a multiplicity of 2, and that would be at the -2. So I have to bounce here. Okay, and I got my f of -1 is equal to 2, so up 1, 2. So it kind of goes up to 2 and then crosses like a line right there. So that way you can kind of get a nice little picture of the graph. Right now, I'm going to let you guys come over here and do this one on your own and answer a question about that. Oh, I did want one more thing before I kind of leave part A behind. You got to be careful about making assumptions. And you notice that I put that negative or that positive to -1, 2 point on there. I kind of assumed that that was the maximum there, that relative max. You don't know. I mean, your graph could come up here and then come back down to there. Really, until you get more information. No, I don't know what's going on. All I know is it goes through the point, -1, 2, but I don't necessarily know that's a maximum. So I would back up just a second and say, this is what I do know about it, but it doesn't in any way tell me what is actually happening there in terms of the function. It just goes through that point. So I just thought I would mention that. We're kind of looking at the overall trend as well. If we wanted more detail on this, then obviously we would go and we could use Desmos or calculator to get a little bit more information. So why don't you guys do that? Why don't we go ahead? Let's take a look at the graph of this. So I'm going to pull up Desmos real quick. All right, I pre-entered some information in for us, and let me just make this, oops, I just want to make it black. I want it to kind of show up a little bit more. Turn that on. So if we take a look at this, and I'm going to zoom in. Now, kind of clearly when I look at this, I have the whole graph. I know I have the whole graph because of the shape that we were looking for. This coming down, bounce, go up, and go down. Also, kind of notice I put in the original equation, not my factored form, just to make sure that what I discovered with the factored form was correct. And I also put that point that I found -1 and f of -1 on the graph as well, because I wanted to see where it was. I wanted to show you that we, like I said, don't make assumptions about this. We can see that it goes through that point. It gives us a little bit of information, but not necessarily what the maximum is. All right, so now I truly am going to stop and I'm going to let you try this one on your own and be prepared to answer a question about it. All right, and then I'm also gonna make sure that when you do this, you can check this in Desmos. I mean, you've got tools available to you, so I'm not necessarily going to do each of these. Now, what I want you to do for each of the font, like this pretty much we're gonna finish up this set of notes right here, is go ahead and these are already factored, so these are even nicer. Now, the techniques I used up here, I just did a GCF and a quadratic factoring. In B, I did a factoring by grouping. And remind you, I could throw in a synthetic division in there somewhere on this. But what I want you to do for each of these is just do a rough sketch. Using the end behavior, sketch the zeros and multiplicity. I did that as 1. Maybe I also want to go ahead and do the state the end behavior, because that's also kind of important so that you know what's going on there. You might want to think about what the lead coefficient is because you don't have it, but you do not need to multiply the whole thing out. You should be able to very quickly look at something and tell me the lead coefficient. Now, a lot of these are very, very easy because the lead coefficient comes from multiplying the three things that have the highest power on them. And in this case, like in f of x, it's x, x, and x. So if you were to multiply those three things times each other, you would end up with kind of at the same spot. So I'm trying to get this to update. Let me click off and click back on. Yeah, there we go. So if I multiply those three things out with the highest powers on them, that would give me the lead coefficient. And so the lead coefficient, if I were to multiply it out, would be x cubed plus a bunch of stuff. And then the constant at the end would be the constants 2, -1, and -3, which would give me +6. So you actually can do that kind of in your head. And why would I want those two things? Degree, lead coefficient, and the constant term gives me my y-intercept. So you should have x-intercepts correct on your graph, y-intercepts correct on your graph, end behavior correct on your graph, and the general shape of what's going on correct on your graph. Again, in a lot of these, we are assuming that there are no complex zeros, so there's none of that funny stuff that we have to worry about with that. Once you get your rough graph down on the paper, pull up Desmos or your calculator, graph it on your calculator, verify that your shape is the shape that you see on the calculator. Then you'll finish up. Your homework is going to be this worksheet on graphs of polynomial functions. So that's going to wrap this one up. So you guys have a good evening and just work on the worksheet. I forgot one more thing before we leave is that the other item that you have for homework slash classwork, working on this set of notes, is there are 3 FRQs. So if I come over here and we scroll down, here's FRQs 3, 4, and 5. So will you include those in as things that you are going to look at? And you'll notice that here in the first one, that what I'm doing is I'm giving you some information about the behavior of the graph, and then I'm going to be asking you to answer some questions. So I'm giving you properties and then asking you questions about the function. In the second one, I'm giving you the algebraic formula for it and then asking you questions about the function. So we kind of did verbal, then we did algebraic, and then down here we have a numeric FRQ where I give you a table of values and ask you questions about the function. So in general, your final thing for everything in this day's notes, you had 3 videos to watch, 2 on this set of class notes and 1 on the properties that came before. You have worksheets to do for both class notes, and you've got some FRQs for practice. And so pretty much you should be able to do the worksheets and all the class notes in class, in our class time, and then the homework is actually the FRQs. All right, and then we'll come back in on the next day that we have here. We're going to be looking at more rational equations and rational functions. So we're going to switch gears from the polynomials and looking at the real zeros of polynomials and heading into rational functions, what happens when we start to divide polynomials. So that'll be where we're headed. All right, you guys have a good night.